This is lesson B in Algebra 2, perimeter area, volume, surface area, and sectors of circles. So this is pretty much review, but it's a lot of geometry throughout the book in Algebra 2. If you remember that the perimeter of any object is the distance from a point on this case a polygon, this length plus this length plus this length plus this length. So it's basically, if this object were a backyard and you wanted to fence this in, how much fence it would take in order to fence this yard in. So you would just add up all the sides. Now when we're dealing with a circle, we're looking at a perimeter, the distance around, but a circle has another word for perimeter, and it's called circumference, and it's the distance from here all the way around to back where we started. Again, some more definitions here just to remind you. The radius is the length from a point at the center of the circle to any point on the circle. So that length there is the radius. A chord is the length, or not necessarily the length, but it is a line segment that goes from one point on the circle to another point. So you draw a point anywhere on the circle and you get a chord. Now notice what happens here when I put my point here and I go through the center point of the circle. That is a special chord called the diameter. The next thing we're going to talk about is pi. If we have a circle and we have a diameter, and we take the length of the diameters, or the diameter here, and maybe we use a piece of yarn and we stretch it across here, get this length, and we put one piece of the yarn there and we stretch it across here. We use yellow here. We stretch it across here, and there's one diameter. There's two diameters. There's three diameters. Doesn't quite get there. This distance that we're missing is 0.14. So what do we have? 1, 2, 3. 3.14 diameters in the circumference. 3.14 is written as pi. In fact, this 3.14 goes into infinity. If you look at the top of page 9, it gives you a little bit larger amount of decimals there in pi. Okay, so next section, it has to do with area. The area is, like I had mentioned earlier, if we had a rectangular yard and we wanted to fence it in, the perimeter would be how much fence we need. Well, the area would be how much grass seed we would need to plant, how big the yard is, and the way you find the area of a rectangle is length times width. So if this were 4 and this were 2, the area of that would be 8. But when we're talking about a circle, because we don't have a length and a width, it's a little bit different. And the length, or the area of a circle is going to be pi r squared. So that's the area of a circle. Now going back to circumference of a circle, the distance around, so if we start here and go all the way around there, we have two options here. We can take pi times the diameter, or we can take 2 times pi times the radius, 2 pi r, because 2 times the radius would be the same as the diameter. So that's how you would find the area of a circle. Now if we've got a triangle, what we have when we have a triangle is we actually have two triangles would make up a quadrilateral, which the length, or the area of this quadrilateral, would be length times width. Well, in this one we only have half of a quadrilateral, so we have 1/2 the base times the height. The length of this times how high it is. Now, when we're dealing, let me draw another picture here for just to get rid of all this mess. if we have a triangle like this, the base is right here. This is not the height. The height is not this length, nor is it this length. The height of this triangle is a line segment perpendicular to the base, remember 90-degree angle, to the other vertex. That is the height. So 1/2 base times height would be 1/2 the length of the base and times the perpendicular height of that triangle. So if we had a right triangle, that's already the perpendicular. So if this is 4 and this is 3, it would be 6, 1/2 base times height. If we had a triangle that looked like this, and we knew this was 3 and this was 6, we cannot find the area of this unless we know the height. So let's say that's 2. Now we can say the area of the triangle is 1/2 base times the height. So we can just take half of either one of these numbers and multiply it by the other one. So half of 6 is 3, 3 times 2 is 6. Or half of 2 is 1, 1 times 6 is 6. So either way will work as far as finding the area of a triangle. Now this is example B.1 on page 10. It says find the perimeter and the area of this figure. Now, one of the things that we're going to have to do when we find let's find the area first, is we have to break this up into different things. So I'm going to break this up into things that I know. I know I can find the area of a triangle, I know I can find the area of a square, and I know I can find the area of a half circle. So let's start with the area of the square. So the area of the square is going to be 4 times what? We got this length, but now we have to find this length. Well, if I know that the radius is 2, that means the length from here to here is 2, and the length from here to here is 2, then I know this whole length right here is going to be 4. So 4 times 4 will be the area of that rectangle. Now the area of the circle is going to be pi r squared, and I know my radius squared is 4, so it's 4 pi, which would be 4 times 3.14, and that would give us the area of that circle. But we only want half the circle, so we're going to take our 4 times pi and divide it by 2. So 4 times pi is going to be 12.56. I'm going to divide it by 2, and we get 6.28 for the area of the half circle. Alright, so let's look at the area of the triangle. We have the height of the triangle right here. This distance right here is the same as this distance here, so we have 4. So our area is 1/2 base times height. So we have the height, so that's 4. Now we have to find what the base is. We know that the length from here to here is 7. And we know the length from here to here is 4. So that means the length from here to here has to be 3. So we're going to take 4 times 3 is 12, and then take half of that, and that gives me 6. So my area of my triangle, area of my half circle, area of my rectangle, if I add all those up, I get 28.28, and that ends up being the area of that object.